In most areas, electrical work must be performed by a licensed electrician. It is recommended to check the local regulations. However, preparatory steps for an electrician's visit can involve purchasing materials and running the conduit. All electrical work requires inspection and approval by a licensed electrician or an electrical inspector. It is generally better to run one continuous cable from the meter to the connection panel to avoid potential failure points from underground splices. Based on the amperage of the service entrance, a 3-conductor service cable with a ground wire is required. For a 100 amp service, a 4/0 American wire gauge service cable would be needed. Either aluminum or copper cable can be used. Regarding available wires, none listed are suitable for use as a service entrance cable. 4 individual THHN cables consisting of 2 hots, a neutral, and a ground, or a 3-conductor service cable with a separate ground wire can be used. There is no problem with running 4 separate wires. For reconnecting cables in the garage, either a junction box or a small panel box can be used. A riser needs to be installed to ensure the cable is 10 feet above grade. Make sure to bury the conduit deep enough with a minimum depth of at least 18 inches. Use proper conduit fittings and follow all code requirements. Exercise caution to avoid damaging the service cable when pulling it through the conduit. Ensure all cables are clearly labeled and that all electrical connections are tight and secure. When planning electrical service upgrades, several crucial aspects must be considered to ensure safety, compliance with local codes, and long-term reliability. The choice of cable, proper installation techniques, and adherence to regulatory standards are paramount. Firstly, cable selection depends largely on the amperage of the service. For instance, a 100 amp service typically requires a 4/0 American wire gauge cable, whether using aluminum or copper. It's important to note that the specific type of cable required for a service entrance must meet stringent standards for durability and safety. Secondly, underground conduit installation is a critical component of a service upgrade. The depth at which the conduit is buried is crucial, with a minimum depth of 18 inches generally mandated to protect the cables from physical damage and environmental factors. Proper conduit fittings are essential to maintain a secure and waterproof enclosure for the cables. Thirdly, pulling the service cable through the conduit requires careful technique to avoid damaging the cable's insulation. Lubricants designed for cable pulling can reduce friction and minimize the risk of abrasion. Additionally, labeling all cables clearly is a best practice that simplifies future maintenance and troubleshooting. Ensuring that all electrical connections are tight and secure is non-negotiable. Loose connections can lead to overheating, arcing, and potentially hazardous situations. Torque specifications for connectors and terminals should be strictly adhered to. The use of a junction box or small panel box for making connections in the garage provides a safe and organized enclosure for splices and terminations. When transitioning from underground to above-ground installations, such as at the garage, a riser is typically required to elevate the cable to a safe height, often 10 feet above grade, to prevent accidental contact. The NEC, or National Electrical Code, provides comprehensive guidelines for electrical installations. Compliance with the NEC is mandatory to ensure safety and regulatory compliance. Local jurisdictions may also have additional requirements or amendments to the NEC, so it is crucial to consult with local authorities. Electrical work, particularly service upgrades, often requires permits and inspections. Obtaining the necessary permits before starting the project ensures that the work will be inspected and approved by qualified electrical inspectors. Inspections verify that the installation meets code requirements and is safe for operation. When working with electrical systems, personal safety is paramount. Always de-energize circuits before working on them and use appropriate personal protective equipment, such as insulated gloves and safety glasses. If there is any doubt about your ability to perform the work safely, it is best to hire a licensed electrician. Furthermore, when evaluating the use of existing wires or cables, it is essential to verify that they are suitable for the intended application and meet current code requirements. Often, older cables may not have the necessary ampacity or insulation rating for modern electrical loads. Finally, consider the long-term maintenance and accessibility of the electrical service. Designing the installation with future maintenance in mind can save time and money in the long run. Provide adequate access to junction boxes, panels, and other components for inspection and repair. By carefully considering these factors and following best practices, an electrical service upgrade can be performed safely, reliably, and in compliance with all applicable codes and regulations. When undertaking electrical work, especially a service cable upgrade, several key considerations should be taken into account to ensure safety, compliance, and optimal performance. Firstly, understanding the local electrical codes and regulations is crucial. Electrical codes, such as the National Electrical Code in the United States, provide detailed guidelines on how electrical systems should be installed and maintained to minimize hazards. Local jurisdictions may have additional requirements that must be followed. It is essential to consult with local authorities or a licensed electrician to ensure full compliance. Secondly, selecting the appropriate type and size of cable for the service entrance is paramount. The cable must be rated for the amperage of the service and the environmental conditions in which it will be installed. For example, underground cables must be suitable for direct burial or installed in conduit to protect them from moisture and physical damage. Aluminum and copper cables have different properties and ampacity ratings, so it is important to choose the right material for the application. Thirdly, conduit installation is a critical component of underground electrical work. Conduit protects the cables from damage, provides a raceway for easy cable replacement, and helps to contain electrical faults. The type of conduit used depends on the application and local code requirements. PVC conduit is commonly used for underground installations due to its resistance to corrosion and ease of installation. Rigid metal conduit provides superior protection but is more expensive and difficult to work with. Fourthly, proper grounding is essential for electrical safety. A grounding system provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. The grounding conductor must be sized appropriately for the service and connected to a grounding electrode, such as a ground rod or water pipe. Fifthly, making electrical connections requires careful attention to detail. Connections must be tight, clean, and properly insulated to prevent overheating, arcing, and electrical faults. Torque specifications for connectors in terminals should be strictly adhered to. The use of approved connectors and splicing methods is essential for maintaining the integrity of the electrical system. Sixthly, labeling all cables, wires, and components is a best practice that simplifies future maintenance and troubleshooting. Labels should be durable and easy to read, even after years of exposure to the elements. Clearly identifying circuits, wire sizes, and voltage levels can prevent confusion and errors during future work. Seventhly, performing electrical work safely requires the use of appropriate personal protective equipment. Insulated gloves, safety glasses, and arc-rated clothing can protect against electrical shock, burns, and other hazards. Always energize circuits before working on them and use lockout/tagout procedures to prevent accidental re-energization. Eighthly, inspections are a critical step in ensuring the safety and compliance of electrical installations. Local authorities typically require inspections for new installations and major modifications to existing systems. Inspections verify that the work meets code requirements and is safe for operation. Failing an inspection can result in costly rework and delays. Ninthly, considering the long-term maintenance of the electrical system is important. Designing the installation with future maintenance in mind can save time and money in the long run. Provide adequate access to junction boxes, panels, and other components for inspection and repair. Use durable materials and construction methods that will withstand the test of time. Tenthly, when in doubt, consult with a licensed electrician. Electrical work can be dangerous and complex, and it is best to leave it to the professionals. A licensed electrician has the training, experience, and knowledge to perform the work safely and in compliance with all applicable codes and regulations. By carefully considering these factors and following best practices, an electrical service upgrade can be performed safely, reliably, and in compliance with all applicable codes and regulations. Remember, safety should always be the top priority when working with electricity. When planning and executing an electrical service upgrade, several critical aspects demand meticulous attention to ensure safety, regulatory compliance, and long-term reliability. These considerations span from initial planning and cable selection to installation practices and safety protocols. Firstly, a thorough assessment of the existing electrical system is essential. This involves evaluating the current service capacity, identifying any existing deficiencies or hazards, and determining the required capacity for future needs. An accurate load calculation, considering all electrical appliances and devices, helps in determining the appropriate size of the service entrance. Secondly, cable selection is a crucial step that directly impacts the safety and performance of the electrical system. The cable must be appropriately sized to handle the anticipated load and meet the requirements of the National Electrical Code or other applicable standards. Factors such as voltage drop, ambient temperature, and installation method must be considered when selecting the cable. Aluminum and copper cables have distinct properties and ampacity ratings, so it's vital to choose the material that best suits the application. Thirdly, conduit installation plays a significant role in protecting the service cables and ensuring their longevity. Conduit provides a physical barrier against mechanical damage, moisture, and other environmental factors. The type of conduit used depends on the installation environment. PVC conduit is commonly used for underground installations due to its corrosion resistance and ease of installation. Rigid metal conduit offers superior protection but is more challenging to work with. Fourthly, grounding is a fundamental aspect of electrical safety. A properly installed grounding system provides a low impedance path for fault currents, minimizing the risk of electrical shock and equipment damage. The grounding conductor must be sized appropriately for the service and connected to a grounding electrode, such as a ground rod or water pipe. All metallic enclosures and equipment must be properly bonded to the grounding system to ensure electrical continuity. Fifthly, making electrical connections requires precision and attention to detail. Loose or corroded connections can lead to overheating, arcing, and potential fires. Connectors and terminals must be properly sized and torqued to ensure a secure and reliable connection. The use of approved splicing methods and materials is essential for maintaining the integrity of the electrical system. Sixthly, labeling all cables, wires, and components is a best practice that facilitates future maintenance and troubleshooting. Clear and durable labels can prevent confusion and errors during subsequent work. Labels should include information such as circuit identification, wire size, and voltage level. Seventhly, safety must be the paramount concern throughout the entire process. Working with electricity can be hazardous, and proper precautions must be taken to minimize the risk of injury or death. Always energize circuits before working on them and use appropriate personal protective equipment such as insulated gloves, safety glasses, and arc-rated clothing. Lockout/tagout procedures should be implemented to prevent accidental re-energization of circuits. Eighthly, inspections are a critical step in verifying the safety and compliance of the electrical installation. Local authorities typically require inspections for new installations and major modifications to existing systems. Inspections ensure that the work meets code requirements and is safe for operation. Failing an inspection can result in costly rework and delays. Ninthly, long-term maintenance should be considered during the design and installation phases. Providing easy access to junction boxes, panels, and other components can simplify future maintenance and repairs. Using durable materials and construction methods can minimize the need for future repairs. Tenthly, when in doubt, consult with a licensed electrician. Electrical work is complex and potentially dangerous, and it's best to rely on the expertise of a qualified professional. A licensed electrician has the training, experience, and knowledge to perform the work safely and in compliance with all applicable codes and regulations. By carefully considering these factors and following best practices, an electrical service upgrade can be performed safely, reliably, and in compliance with all applicable codes and regulations. Remember, electrical safety should always be the top priority.